Let's take a look at inverse properties of logs. Let's decide that f of x will stand for the function b to the x, exponential function base b of x, and f inverse of x will be the inverse function, which is log base b of x. Now we know that when you compose two functions that are inverses of each other, then if you were to have an input of x, the output would be x as well. So f inverse composed with f of the quantity x is going to be x. And similarly, f composed with f inverse of x would be x. So if we wanted to evaluate those two for the two functions mentioned above, then f inverse composed with f of x is, by definition, f inverse of f of x. Now f of x, f would be the inside function and f inverse would be the outside function. So what we're trying to do is take what f of x is worth, which is b to the x, and plug it inside the log base b of x. So imagine this whole quantity b to the x being plugged in right here where x is. So you would have log base b of the quantity b to the x would be equal to x. Now, if you were to compose the other way, f composed with f inverse of x is f of the quantity f inverse of x. So f inverse of x would be the inside function and f would be the outside function. So the inside function is f inverse of x, which is worth log base b of x. If you were to plug that in where x, the variable, is right here in the function f, you would get b raised to the exponent log base b of x, and that would be worth x. Thus we have log base b of the quantity b to the x would be x, and b raised to the log base b of x would be x as well. Now just take a look. For this to work out, okay, we do need to have the same base right here and right there. Look, base b here, base b there. And what happens is, like, if the log base b cancels with b being raised to a power, those two cancel each other. They are inverse functions of each other. And the exponent x gets freed up and falls down to the level of writing. So you write it on the other side of the equal sign. Similarly, if you have b raised to the log base b of x, notice the bases are the same again, base b in both places. So it's like if this b to the power cancels with log base b, and again the x is freed up and we get x as an answer. Let's take a look at some examples on how to use those properties. Log base b of b to the x is x, and b raised to the log base b of x is x as well. Okay, remember we need the same base, and then the log base b cancels with b raised to the exponent, and then the exponent x in this case falls down, and that's my answer. Let's say we had log base 5 of 5 to the x. Notice in both cases here and there, the base is going to be 5 for the log and for the exponential function. So the log base 5 cancels, the 5 to the power cancels, and then x, which is the exponent right here, falls down, and that's our answer. Now what if we had log base 5 of 5 raised to the pi? Now notice 5 is a base, and here and there, both places. So the log base 5 needs to be crossed out with 5 to a power. Now the power pi falls down, and that's our answer.